This video, we're going to talk about what's referred to as the periodic table, more specifically, the periodic table of elements. And we're going to see how elements are arranged and what information we can tell based on this arrangement. So elements are going to be arranged in order of their atomic number, so specifically in order of increasing atomic number. So hydrogen, for example, has the atomic number of 1. It has 1 proton. If it's a hydrogen without neutrons, it would have this elemental symbol here. So we expect to see hydrogen first on the periodic table. We're going to see that there are rows on the periodic table, which are called periods. So going from left to right horizontally, we have periods or rows. And then we have columns, which are vertical. And these columns are referred to as groups. Elements that are in the same group have the same reactivity and similar chemical properties we're going to see. So let's take a look here at some of these groups that have specific names. So we see here in group 1A, so the main group 1 elements have the common name here, or the name alkali metals, and that includes these elements listed over here. So we have lithium, sodium, potassium, rubidium, cesium, francium. And then if we look in our periodic table down below, we can see that in group 1, below hydrogen here, if we go down this column, we can see lithium, sodium, potassium, etc. So these are the alkali metals. Group 2 contains the alkaline earth metals, so beryllium, magnesium, and the rest. Then we have group 6. Group 7, this is a common name that you should know as well. These are called the halogens, so that's this group here, 7A, this vertical column, which includes fluorine, chlorine, bromine, iodine. And then we have our last column here that has a common grouping. These are the noble gases in 8A here. So we have helium, neon, and argon that start. So again, the noble gases, you should know that name, the halogens, definitely alkali and alkaline earth metals. So looking at the periodic table again and the way that it's organized, we're going to gain more information in a later chapter. But for now, we should know that the columns are called the groups, and we have 8 main groups. So generally, we don't count this portion here. These are called the transition metals. So our 8 main groups are designated with the A after them. And we can see that there is some different color coding down here, that all the metals on the periodic table are in the yellow shading. Then we have what are referred to as metalloids. So we have boron, silicon, germanium, and the rest here in this purple color that form this kind of staircase here. And we refer to this staircase as separating our metals on this side, so all the yellow, from our nonmetals, which are in the green here. So we'll look at when metals and nonmetals combine, or all nonmetals, how we get different types of compounds later on. But we should at least know where to locate these different types of elements, including metals and nonmetals. So let's look at sample exercise 4 here and see if we can use some of those organizational properties and aspects from the periodic table to answer this question. So we're asked to see or show which elements would show the greatest similarity in chemical and physical properties. So are they in the same group? Are they in the same row? So we're going to locate these elements on the periodic table. So I can go up above here and we'll remove some of these markings. And let's locate some of these. So we have boron was listed, so I'll box him in. Then we have calcium, which is over here. Fluorine is over here. Fluorine was on the list. We have helium next. So helium is all the way over here. Then we have magnesium, which is right above calcium. And then we have phosphorus, which I'll box in nice and dark here. All right. So the question again is which two of these elements would we expect to show the greatest similarity in reactivity? So we have some that are in the same row, like magnesium and phosphorus. We have boron and fluorine that are in the same row. Um, but if we're in the same period, that doesn't really tell us anything about reactivity. But we see over here, both magnesium and calcium are group 2. So we would expect them to have the most similar reactivity. So the answer to this question would be calcium and magnesium because they are in the same column. So same column, same reactivity.